Hello, my name is Yikong from FTC Cattlebots 20344, and today we're using Onshape, which is a computer-aided design or CAD software. In FTC, CAD is how we design robot parts, plan mechanisms, and make sure everything fits together before we build. Onshape lets us create 2D sketches and 3D models, and it's especially useful for FTC because it's free for students, cloud-based, and allows multiple team members to work on the same project. Let's start with Onshape navigation. When you log into Onshape, you'll see the documents you've worked on, particularly the most recent ones, folders, and all the documents you have. To create a new document, click Create in the top left, then click Document. Once you create a new document, you'll see the workspace where you can view and interact with designs, the view cube where you can click faces or corners to rotate the model, the toolbar which allows you to create and modify parts and assemblies, the document tab which contains all the part studios and assemblies in the document, and the features or instances panel which usually includes parts and or assemblies. You can select by left-clicking, box select by clicking and dragging, or multi-select by shift-clicking, pan by using the middle mouse button and dragging, rotate by right-clicking and dragging, and zoom by using the scroll wheel. You can navigate using either a mouse or a touchpad, but using a mouse to navigate Onshape will be much faster. A part studio is where individual custom robot parts are designed. When you create a new document, it will automatically open to a part studio. To create a new part studio, click plus in the bottom left, click Create Part Studio, and rename the part studio as necessary. Next, let's look at 2D sketches, which are the starting point for most custom parts in Onshape. Click Sketch in the toolbar, then click one of the planes to sketch on. You'll see a different toolbar when you sketch, which includes geometric sketch tools, sketch modification tools, and dimension tools, as well as constraints. Generally, the most common tools you'll use are Line, which creates a straight line defined by 2 points, Corner Rectangle, which creates a rectangle defined by 2 points at opposite corners, Center Point Circle, which creates a circle defined by 2 points, one at the center and one on the circumference, Trim, which removes a sketch entity, Dimension, which displays a measurement or can adjust a measurement, Use, which allows you to use another pre-made shape when working on a different plane or sketch than your original planar sketch, and Constraints, such as coincident, parallel, and tangent, which help control shape, size, and geometric relationships of sketch entities. After finishing the 2D sketch, you can confirm that you're done by clicking the check mark, and now you're ready to extrude the sketch into a 3D part. To extrude, click the faces and sketch regions you want to extrude and enter the extrusion depth. Let's practice making a simple 2D sketch and extruding it into a 3D part. You might also want to transform a part. To do this, click Transform and select what you want to transform. From there, you'll be able to apply a variety of modifications, such as translating, rotating, duplicating, and scaling parts. After parts are created, they can be brought into an assembly. An assembly is where we check how parts fit together and move, and are especially helpful in FTC for testing spacing, alignment, interactions between parts, and overall robot size. When you create a new document, an assembly is automatically created. To create a new assembly, click plus, click Create Assembly, and rename the assembly as needed. What you'll mainly be doing in an assembly is adding mates, also called joints. The most common mates you'll work with are fastened, which restrict translational and rotational freedom of movement for both parts, and revolute, which restrict translational but not rotational freedom. When applying mates, you'll usually insert the parts you need first. To insert a part or assembly, click Insert. You can either choose to insert from the current document or another document by clicking Current Document or Other Documents respectively. Depending on what you want to insert, click either Part Studios or Assemblies. Onshape also provides us with FTC parts that can be easily inserted, allowing assemblies to be completed more efficiently. Now I'm going to add a mate. Before doing so, always make sure that both parts are in the correct orientation. You can click and drag the arrows and circles to rotate. Click a mate connector on one part and click a mate connector on another part. If you want to make changes to the mate, you can either change the type of mate or add an offset, which allows you to apply additional translations or rotations. Click the check mark to confirm the mate. Let's look at how to import and export. To import a part or assembly, click plus, then Import. Select the file to import and click Combine to a single part studio for small assemblies or import to this document otherwise. Then click Import. To export a part or assembly from the Instances or Features panel, right-click the instance or feature, click Export, adjust, export details as needed, then click Export. To export a part studio or assembly from the tab bar, right-click the part studio or assembly from the tab bar, click Export, adjust export details as needed, then click Export. By following these processes, Onshape becomes a powerful tool for designing, testing, and improving FTC robots before building anything. Thank you for watching today's video, and don't forget to visit scoutthebots.org.